What's going on, math people? We are back again, and today we're going to be talking about the graph of a function. This will be a really straightforward lesson, and to jump straight into it, we're going to go into the vertical line test. First of all, let's just make sure we're all on the same page with what a vertical line is. Vertical line is a line that goes up and down, all right? Now, vertical line test, there's the math jargon right there below. A set of points in the XY plane is the graph of a function if and only if every vertical line intersects the graph in at most one point. All that is saying is if you draw vertical lines anywhere through a graph and that vertical line only hits one time, then that graph is a function. Draw a vertical line on the graph. If it hits one time, it is a function. And just to go from the previous lesson, it's to be a function, the x values cannot repeat. On a vertical line, the x values are all the same value. No matter what the y value is on the x value, they're all the same. All right. So let's move on forward. All right. So it says which of the following are graphs of functions? We're gonna look at this. We just drop vertical lines through. That vertical line hit one time. I dropped another vertical line right there, hit one time. No matter where I draw a vertical line, it's only gonna hit once. So that is a function. Do the same thing over here. One time on the graph. One time. If we only hit vertically one time, what do we have? A function. Thank you. All right. Let's keep rolling. Oh, game. What? 1, 2. Well, that ain't no one time. That's a 1-2 time. Ain't nobody asked for a 1-2 punch. That is not a function. We want a one-time knockout, TKO, not a function because you had to hit twice. Oh, you ain't in the game. Not a function. Had to hit twice. Fail the vertical line test. That's the mathematical way of saying it. So I'm going to say it the mathematical way. According to the vertical line test, the vertical line intersects the graph at more than one location. Therefore, this graph would not be representable of the graph of a function. I don't know why. I felt like that was just a typical mathematician from back in the day voice. All right, moving forward. All right. It says, obtain the information from the graph of a function. What are f of 0, f of 3 pi over 2, and f of 3 pi? So first of all, we need to make sure we understand that f of x. All right. X is the input. F of x is the output. F of x is also representative of the y values. All right. Now let's read this again. This is saying, what are the y values associated with the 0, 3 pi over 2, and 3 pi? So I'm going to go to 0. This would be f of 0 would be 4. I went to the x value of 0 because my input was 0 and my output would be 4. I went to 3 pi. I go to 3 pi over 2 here. My input is 3 pi over 2 and my output value is 0. And I go to 3 pi. My input value is 3 pi and my output is -4. All right. What is the domain of the function? Question, do you see any breaks in that graph? Do you see any gaps? No gaps. All right, since you see no gaps, you see that that function is a continuous function, but it's not continuous, infinitely continuous. It has starting and ending points. And the domain, we're going to focus on the x-axis. So this graph starts at an x value of 0. it starts at an x value of 0 and ends at an x value of 4 pi. So the domain of this function is from 0 to 4 pi. We put brackets because those are the ending locations. Alright. What is the range? For the range, we look at the y-axis. Alright. So looking at the y-axis is the range. You want to see how high the function goes, how low the function goes. If you can measure how high it goes, that's letting you know it's not going to infinity. This graph goes, the highest it goes is 4, the lowest it goes is -4. So the range of this function would be from -4 to +4. Domain associated with the x values, the range associated with the y values. Okay, and let's keep going. It says list the intercepts. I'm going to clear this other stuff off the graph right quick so that we can see our intercepts. If we remember from previous lessons, intercepts are the locations where the graph crosses or touch an axis. All right. And so we're going to identify the y-intercept first. Boom. The y-intercept is right there, 0, 4. That's the only y-intercept. And then let's go ahead and also identify the x-intercepts. Crossing the x-axis, crossing the x-axis, crossing the x-axis. We have 4 x-intercepts and 1 y-intercept. So we have pi over 2, 0. 3 pi over 2, 0. And 5 pi over 2, 0. And finally 7 pi over 2, 0. Alright. How often does the line y equal 2 intersect the graph? Now you have to remember that y equals 2 is a horizontal line. So I'm going to go to the x value of 2 and draw this horizontal line. How often does the line y equal 2 intersect the graph? This orange line is the line y equal 2. It intersected 1, 2, 3, 4 locations. So you can say 4 times. Then this part F says, for what values of x does f of x equal -4? So it's saying what input values produces output values of -4. All right, circling those in blue. Inputs producing outputs of -4. Those inputs would be pi and 3 pi. And then finally, this problem says, for what values of x is f of x greater than 0? So saying, whereas when it's asking greater than 0, you're looking at everywhere the graph is above. Everywhere the graph is above the x-axis, because you want that's saying the y values are positive. So here is greater than 0. This stuff right here, all of this stuff, greater than 0. Now, how to write that out? So for what values of x, all right, I'm going from 0. Let me change this over right quick. Let me put this back on pencil. I'll write it in black. So we're going from 0 to pi over 2. And I'm going to put a parenthesis because at pi over 2, the output is 0 and we want everything greater than 0. Then I'm going to put union. Some people will put a comma. We're going to start again from 3 pi over 2 to 5 pi over 2. and then one final time from 7 power 2 until we get to 4 pi. Bracket on 4 pi, because 4 pi has an output that is greater than 0. Okay. And this one takes a little practice, but hey, I believe in you. I believe in you. Yeah. Anyways. Determine whether the graph below is that of a function by using the vertical line test. If it is, use the graph to find its domain and range. All right. We're going to go ahead and get our vertical line test popping. The vertical line test, we dropping vertical lines. We got the one punch. So it is a function. It says if it is a function, use the graph to find its domain and range. All right. We've determined that it is a function. Now to go to the next phase. All right. To find the domain. This graph will never cross the y-axis, but it's going to the right forever. And so our domain is going to the right forever from the y-axis. The domain would be all x values that are from 0 to infinity. That is the domain. Now the range, this graph is going up and down forever. I don't care if it's going up and down at an angle, it is going up and down forever. Therefore, the range of this function is all real numbers in interval notation that is written from negative infinity to positive infinity. I'm in my nice squeaky old chair. All right. The intercepts, if it has intercepts, identify those intercepts. All right. It's crossing the x-axis right there at the x value of 1. So we have one intercept, and that is 1, 0. Symmetry is symmetric to nothing. No symmetry. So we're going to write none, because it doesn't look the same on the left and right of the y-axis or the above or below of the x-axis. All right. Again, same rules apply. Run this vertical line test. Drawing those vertical lines, we got one punch everywhere. So that is a function. So that means we have to do all that other stuff that we just did. We have to find the domain, have to find the range. All right. Find the domain. All right. When we look in left or right, there are no breaks in that graph. So that domain is all real numbers. Now to check the range. Checking the range. This graph has a peak, but it does not have a bottom. It goes down forever. So the range, since it's going down forever, it's going to negative infinity, but the highest it goes is positive 8. And it has intercepts. It has X-intercepts, 2 X-intercepts, and 1 Y-intercept. Those intercepts. So the Y-intercept is 0, 8. The X-intercepts are, let me erase some stuff so I can see. It's counting by 4s. So those X-intercepts are negative 4, 0. I'm sorry, that's negative 8, 0. And positive 8, 0. All right, so we have our intercepts. It looks the exact same on the left and right of the y-axis. So we have y-axis symmetry. And that's the only symmetry we have for that example. Okay. Okay, and then we have to put some stuff back into this graph. Or well, into this function. I don't know why I lose some of the characters, but anyways. We have, is the point 1/1/2 on the graph of the function? So what you want to do, you understand that 1 is the input, 1/2 is the output. So what I'm going to do is take that function and I'm going to input 1 for x and see if I get 1/2. And by George, I think I've got it. Therefore, the answer is yes. Then the problem says if x equals 2, what is f of x? Again, x is the input, so I'm going to take 2 and plug it into that function to find out what my output is, and that would give me 2/3. So f of x, f of 2 would be 2/3. And then it says what point is on the graph. The point that's on the graph would be 2/3. Then part C says if the output is 2, what is x? So we're going to write 2 equals x over x plus 1 and solve for x. Solving for x, you have 2 times x plus 1 equals x. We'll distribute the 2. That gives us 2x plus 2 equals x. And we'll move all the variables on one side. We have 2 equals negative x. Dividing by negative 1, we have x equal to negative 2. Alright, so that is the answer for the first part of that. And then to find out what the point is x value negative 2, and the output that was given, positive 2. Shebang. Alright, look over that. And let's move on to the next. The average cost. Average cost of manufacturing X computers per day is given by this function. Alright, so it already gave you the average cost function. And it says, notice it says, give me a different little color. X computers. X computers. It says determine the average cost of manufacturing. Part A says 30 computers. So that's letting us know right here that X is equal to 30 for part A, X is equal to 40 for part B, and 50 for part C. And so each time you would just plug in X into the function. And I'm recommending you using a calculator to do this unless you have ultra brain power, and I don't. Alright, and that's that. Alright, team, I will see y'all next time with some more math for my math people.